this connection here, which connects up to the same schema, but instead it's connecting with a different JDBC driver, connecting with the JProxy driver, which is just a configuration I could change here, and it's connecting to the local host on port 1400, which is the JProxy server listening. So what happens is then when you're using this driver, all the connections are going to the proxy server where there's additional information. It can match up the usernames and such that are here in the connection string. It can match that up to its internal tables to see whether this request should be masked or not. And what they're allowed to do. Are they allowed to do a select statement on this table? And then if so, are they allowed to see the real data? If not, what should the masking on that data look like? This is just a way of redirecting that. And we don't have to change the source code because we do have the source code of our own application. But if somebody else were using our application and they wanted to be able to have masked data, they wouldn't have to have our source code to change the app. All they have to do is go in here and configure their driver differently. If we didn't have the actual username and password to the Oracle server, we only had the credentials to go to the proxy server, then that would be our only choice for connection. There'd be no way that we could connect directly to the database. So therefore the database would be protected because the only way that we would have to access it through this app would be through the proxy server because that's the only credentials that we have, the only username and password that would be enforced. Now, for an in-house application written by a company for their own use, a lot of times that driver is specified in the source code. There is no configuration. In other words, they write an application to work with their Oracle server, with their data, and they don't provide a configuration for which drivers to use. It's hard coded into their program. But in that case, they have the source code to their program. All they need to do to use the proxy server instead is change 2 or 3 lines of code just where it loads the driver. Just instead of loading the Oracle driver, load the proxy server driver and change the connection string, just like the same 2 things that I would change here in our application in the configuration. That has to be done in their application, and they have to recompile it. In the case of Java, where it's not really compiled, but have to push that out to their user so that they're using the modified version along with that driver. This is the management system for the whole proxy system. Really has 2 components. It has a proxy server. It's just a command line Java application that runs and monitors the network ports for the connections. This is a Tomcat Java application. So this is being accessed through a browser. This is just Chrome. There is a configuration for that JProxy, and you can change out the driver that the JProxy server, it uses a JDBC driver as well to connect to the database. And the end user just uses the JProxy driver because the end user is only connecting to the proxy server, then uses whatever JDBC driver you configure it to use. It's only configured one time. All the clients have to be configured for all the different users with the JProxy driver, but the JProxy server itself uses JDBC driver. Now, there are certain supported ones. We could test with other ones. If you have a specific need, we'll make sure that that's supported. That's part of the configuration of the JProxy server, which is just a configuration file for that JProxy where you specify the drivers and some other details. Also, you have to have a schema on a database that for this system to use. So it uses a database to store all of its information, its configuration, its user lists and database lists and masking policies and things like that are all stored in a database. And we have that on the same Oracle system that we're masking. But in real life, that would be probably in its own database server, just one central server. I believe that can be either Oracle or Postgres. There may be more, but it has to be a relational database with a certain support for foreign keys and constraints and things like that. This is where you would define your proxy servers. We have one proxy server. It's just running locally. Normally, these IP addresses would be somewhere out on the network, wherever the proxy server is being maintained. It wouldn't be the local host like this is. There's accounts the proxy server can use to actually connect to the database. The policies about who is allowed. So you have users on this system. You define users that are users of SQL Sharp. So these can be shared users. You don't have to have one user per every individual that might be using the database through the proxy. But the more you break this down, the more control you have over things like the history, being able to see who it actually was. If you just make role-based users like support and customer service, then you could still have information like which IP address was connected, but you would lose maybe the person's name or something. But that's kind of a design decision that has to be made. Once those users are configured, then these different execute management, policy management, stuff like that, they can be based on the user. So in other words, these users are allowed to connect to this database. This is the database here that's actually where SQL Sharp stores its configuration data. And you can see that only the administrator has access to that. But this is a database that's just a user database. The Scott user, which is an old Oracle demonstration account that's been in Oracle ever since like version 6 or something. So you can see which users are allowed to connect. And there's some default policies that you can apply. These are kind of defaults. A lot of this is explained in the manual. It's a lot to go over here. And then the execute is on for a particular policy name. You can set this and you can add. We don't have any of the users filtered on this right now, but you could filter who can do a select, who can do an update, a create, who can do alter, rename, grant, revoke. All of this is also available in the database, but this just gives you a different layer so that you can have managers or management that can control this access without having to be an Oracle database admin or a Postgres database admin, and less people that actually have access to the actual Oracle system tables. If you change those a lot, there's a possibility you're going to introduce a problem or do something wrong. So if you don't allow very many people to touch the actual database, but you can let them work on these policies and stuff here, it's not nearly as dangerous. It doesn't really take the database down if something goes wrong. It just affects the proxy server, and that can be fixed, and nothing's permanently broken. So you have these extra layers of control of a certain user being able to execute these different types of commands. And then you have the masking, which is the stuff that everybody's interested in, because it lets, as long as you haven't restricted people's access on those other screens, which I haven't, I didn't implement any of that, they can access the database just like they normally could, except that there's going to be these masking rules. And we only have a couple of them configured here. You would, if you wanted to add a new one, you'd give it a name, a description, you'd pick which DB instance it applies to. We only have one. Pick a table. Yeah, so I can browse through, pick the table and the column. If I wanted to mask credit card, and we'll just mask all. I don't think I have any that are just masking the entire thing. So I'll add that one. Then we'll save it. We do have the masking on the orders table, order ID, and the persons table, social security number. Order ID, can't really see it here. It has a masking except the first two characters. There's some predefined rules in here. Masking except the last two characters, masking except the first two, all masking, and then this regex. Regular expressions are a pattern that you create that specifies, what characters or words to search for. This regular expression right here just means any character for a length of 5. So what that does is mask the first 5 characters of the Social Security number and leaves the first unmasked. And I could change that number if I wanted to mask. If I wanted to mask 6 or 7 characters and only leave the last 3 or 2 or 3, because the Social Security number in the U.S. is a 9-digit number. So anyways, let's go ahead and see how that works. This is where we're demonstrating the connections is all. As I explained, this is the connection that goes directly to the database. This is the connection that goes through the proxy server. Normally, we have a username and password that's allowed to use that we have for connecting here. It's Scott, and the password is Tiger. If we go to the other connection here, the one going through the proxy server, but it doesn't have to. We try to keep everything simple here. If we go look directly at the database, do this one a simple way here. We'll look at the table, one of the tables that's masked. I think orders was one of them. So we'll look at the orders table. Just look at the data in it here, just the sample contents in the orders table. Here we see the entire order ID. We see all of every column because we're going directly to the database. We have the credentials to connect directly to the database here, and we did. Here's the way the query looks on this server. When I go through the proxy server, because I chose the proxy server connection up here, which is this one. If I were to switch this to the non-proxy server and execute that same query, then I see the order ID. There's other things in here. I think I already had some of these tabs open. So we don't really have a lot of history because we're not really running an application. If we were running an application, you'd be able to see graphs up here of when the database is in use, when it's busy and when it's not, because it would be constantly keeping the history of all the connections and what's going on. And you can break this down to different databases. You can break it down. You can look for certain things, look for certain users. You can use this not only for database monitoring, also for like forensic. Something happened in the application at 2 p.m. yesterday. It started not working right, or something, transactions started failing. Let's go look and see who was connected, what happened at around 2 o'clock yesterday, and you could narrow down that connection time and range and see who was connecting and look at the queries and maybe determine what had happened, what went wrong, and how to fix it. So it's real good for database forensics, solving problems and stuff.